Hello, everybody. Welcome back to the Board of School Education. We are continuing our lesson on solids, liquids, and gases. So I'm gonna bring you guys over to this chart that you would like to copy down. Pause the video now, and I'll explain the chart right now as we speak. So this is a solid. The molecules held in a fixed pattern but vibrating. So they vibrate here, but they're stuck like this. They can't move around like that. So, by submilling, the solid will turn straight to gas. But that's a tiny bit too advanced, so we're going to move over here. Liquefying or melting will turn the solid into a liquid, which, since what I told you in last video, the heating breaks away all this and expands it so they could move around like that, which will turn it into a liquid. With adult trusting, I mean like with your parents watching, here's an example. Get like a pot, put it over the stove, and put like ice cubes in it to watch it melt. If you put this backwards, liquid over fire will turn it, not liquid over fire. If you freeze the liquid, it'll freeze, solidifying, which will turn it into a solid. Then you could just go back and forth. Oops. You could just go back and forth, 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 forever. If you do it the same forever. I mean, if you heat the water too long, it could evaporate. I mean, heat the water. Besides that, liquid is molecules packed close together in a random fashion, free to move. That's what I was talking about. See how they can move around like that. A solid can't do that. What would happen if you were to boil? Vaporization or evaporating? If you were to boil liquid, there we go, looking for the word, it'll turn into a gas. Molecules widely spread move at great speed. They have barely any room. Like, look, watch this not touch any. I know it touched the bottom, but this is just an example. Watch that not touch any. That's probably all the room that they can move around in. It's really cool. And that's how gas is. If you condole it or liquefying it, it would turn back into a liquid. That's a little bit like 8th grade stuff, I think at least, but we'll skip that. And moving up here, we have the solids, liquid, and gases clip thing video, which I'll be explaining. So, if I have like a video where I run out of time on one, like last video, and have this video, then I won't be like 10 questions each, would be 20 questions. No, this is just continuing off that. If I move on to a new topic like earth science, then that'll be a whole different story. This is solid, liquids, and gases term 2. We're moving on here. So by the end of this lesson, you will know what a material is, what we mean by property, what the properties of solids, liquids, and gases are. So here are materials. Everything is made from same sort of material. Materials are made up of lots and lots of tiny pieces. Think of this way. This is kind of like to matter. No, this is atoms we're talking about right now. So, atoms, they're just like Lego. Like, what? What does it have to do with anything? Wait, how? How atoms are like Legos? Say you build a Lego house. Just like atoms, they build together. If you rip all the pieces off and have one piece left, which is one atom, you can't break that down anymore. These tiny pieces are known as particles, called molecules. It's important. You guys should write this line. Really bad writing I have right now. You should write this line where I highlighted the dot. Write this right here. All of this. Should write that down. It's really important. Solids, liquids, and gases are all made of lots of molecules. That's also another important one that you guys should keep track of. Moving on, properties. Yes, let's get into properties. The property of a material tells us something about what it is like. Materials may be hard, soft, shiny, or rough. Can you think of any more? I'm going to leave that to you guys in the description down below. Not the description. The comment down below. Can you think of any more materials that may be ... dot, dot. You're not copying down hard, not copying down soft, shiny, or rough. Think of your own. Solids, here we go. A solid is something that we can hold on to. It's like you have a brick, you can hold on to the brick. You can hold on to a rock, you can hold on to a notepad, you can hold on to a mouse of a computer. You can hold your dog. That's a solid. Solid is something, oh, I already read that. A solid keeps its shape unless we cut it or shape it ourselves. Oops. What does it mean? What do you mean, what does it mean? What what does it mean? I mean, what it means that if we have like a piece of paper right now and we cut, I don't know, we cut an atom out of it, circle, lots of circles and everything. So we cut that out. Look, it's a new shape now. It's now an atom that we cut out. It's no longer part of this big piece of paper. With that said, in a solid, all the particles are packed tight together very tightly. I already said that and explained that. So we're going to move on. Liquids, here we go. Liquids are runny, like water, as you can see in this diagram right here. It can be poured, like in the diagram. These particles are less tightly packed, so they can move about, just like I said earlier. There should be a little checkup from earlier. If poured from one container to another, they will take the shape of their new container. Yes. So if I were to have this alleged water bottle, I were to flip it upside down so it would land on the cap, which would be so amazing. So if I had like this much water, let's say, I flipped it upside down, so all the water should be around here. It wouldn't be up here because that would not make sense. Can't have floating water unless you're in space. I don't know. I'm not a science teacher. I'm teaching science. Never mind. I'm not sure about that. I'm not sure if it'll be upside down. That's an interesting question. Ask Neil Armstrong or something. But moving on, we have gases now. The particles in gases have lots of room to move. Gases are all around us. No, air is not a gas. Is it? No. I'm not sure on that. Don't quote me. I'm not sure if they're a gas or not. But they spread in all empty places they can, like in a pot when you're boiling something. Yeah, when you're boiling something. Most are invisible. If you know someone or see someone who smokes, you can see the smoke that comes off of the cigarette, which is in fact a gas, or a smoke that comes from a fire. That is a gas. Cars, out of their muffler, you have that gas that comes out of there too. An example, water. Let's move on a little bit more about liquid. We'll move on to water. Water can be a solid, a liquid, or a gas. When it is cold, it is solid, which is ice. When it is at room temperature, it is a liquid, which is water. When it is hot, it is a gas, which is steam. If you steam, like boil soup or something. Water is one of those unique things that can be a solid, can be liquid, and it can be gas. Not all at the same time, or you'll just break the rules of life. Your turn. Okay. Having learned about the properties of solids, liquid, gases, I'd like you to make a list of all of those you know about already. What this means is like list some properties and stuff that you know in the comments. Transactions of states of matter. Or you could write on a piece of paper. I want to move quick because we only have a minute. Transaction means to change. States of matter means transaction, I think, into another state by various ways. The four main are freezing, heating, consisting, and evaporation. I already mentioned that. Freezing. When extremely cold temperatures are applied to a liquid, it will turn into a solid. Freezing occurs when the molecules of liquid slow down enough that the magnesiums cause them to arrange themselves in immovable positions as a solid. For example, when we put water in the freezer, it will turn into iced liquid to gas. So that's what I said earlier. Melting occurs when its heating applies and turns into liquid. When melted, molecules of solid relax and begin to move around freely. For example, when chocolate is left in the sun, it will melt into liquid chocolate, similar to ice left behind in the water. So you could pause it here, and pause. Actually, no, wait, oops, never mind.